Welcome to part one of a two-part series of linear equations in two variables. So we'll start with some basic definitions. First, a linear equation in two variables. This is just an equation of the form ax plus by equals c, where a, b, and c are real numbers, and a and b are not both zero at the same time. Now, a solution to a linear equation in two variables is an ordered pair, that's an x and a y value, that makes the equation true. There are infinite ordered pairs that satisfy a linear equation, and if we plot all of them, we get a straight line. Now, solving a linear equation in two variables really means to graph the line, because we can't just find, well, we could just find one solution, but it's not very exciting. We want to see what all of them are. So we have several ways to do that. The first one is plotting points, and this is where we choose any x value and find the corresponding y value, plot the ordered pairs that we find, and then just connect the dots to form a straight line. So we have two examples here, and I'm going to show you how to graph each of these by plotting points. Okay, so let's take a look at these two examples. First one, x plus 2y equals 8. First thing I'm going to do is set up a table of values to just keep my ordered pairs organized. And I'm going to choose any value for x. I'm going to choose 0. It seems to be a nice easy value to plug in. I'll plug in 0 plus 2y equals 8. So that just gives me 2y equals 8, and dividing by 2, I get y is 4. So my first ordered pair is 0, 4. Next, I'll choose, again, any old point for x that I find is easy, so I'll choose a 1. Plug that in for x, get 1 plus 2y equals 8. Subtracting 1, I get 2y equals 7. Dividing by 2, I get y equals 3.5. So that gives me my next ordered pair. And again, 2 is enough to form a straight line, but I'm going to pick a third just to make sure I don't make any mistakes, and I'll pick 2. So I have 2 plus 2y equals 8. Subtracting 2, I get 2y equals 6. And dividing by 2, I get y is equal to 3. So my third ordered pair is 2, 3. Now I'm going to go to my graph here and just plot these three ordered pairs. My first one is 0, 4. That's on the y-axis. Next I have 1, 3.5. So it's about halfway between 3 and 4. And then 2, 3. Excuse the crudeness of my sketch here. It just gives us a pretty decent idea of where our line is. I'm going to connect these 3 points, noticing that they do seem to line up, and remembering that a line is infinite, so I'm going to extend my line and put arrows on the end. Now for the second example, I see that I have a fraction for the coefficient of x, so I'm going to be careful about what I choose to plug in for x. I want to choose things that are divisible by 3, so that when I multiply by a third, I get an integer. Of course, the easiest thing to plug in is 0, so I'll start with that again. I'll also choose 3 and negative 3. I could also choose numbers like 6, 9, whatever's going to be divisible by 3. So in the first case, I have 1/3 times 0 minus y equals 6. Gives me negative y is 6, so positive y is equal to negative 6. Next, plugging in 3 for x, I have 1/3 times 3 minus y equals 6. Gives me 1 minus y equals 6. Subtracting 1, I get negative y equals 5. And dividing by negative 1, I get y equals negative 5. Finally, plugging in negative 3, I have 1/3 times negative 3 minus y equals 6. Multiplying, I get negative 1 minus y equals 6. So adding 1, I get negative y equals 7. And dividing by negative 1, I get y equals negative 7. So I'm going to plot these 3 points. I'll need to extend my graph a little bit for 2 of these ordered pairs. First one, 0, negative 6. Next I have 3, negative 5. And finally, I have -3, -7, so I'll need to extend my graph again just to get an idea of where that is. And again, these three points should seem like they're going to fall on the same line. And I could just go ahead and sketch that line that should connect them, extending it and putting arrows on the end. Okay, so this brings us to the second method of graphing, and this is finding intercepts. So we're going to just define what an intercept is, and this is a general definition for an x and y intercept. Doesn't only pertain to lines. An x-intercept for a graph is just the point or points where a graph crosses the x-axis. So in this particular case, we have one x-intercept, and for a line, you'll have at most one x-intercept. The y-intercept is the point or points where a graph crosses the y-axis, and here we have this point here. And again, for a line, we will have at most one y-intercept, but for other graphs, you could have more. Now, we want to be able to find these algebraically because we're going to use them to create the graph. So to find the x-intercept, we're going to set the y-coordinate equal to 0, solve for x, and then express the intercept as an ordered pair, which will be some x value and then a 0 for the y. To find the y-intercept, we're going to set the x-coordinate equal to 0, solve for y, and then again write as an ordered pair where the x will be 0 and the y value will be some other value. Alright, let's take a look at an example here. We're going to graph this line by finding the x and y intercepts. We have 4x minus 6y equals 12. So finding the x-intercept first, just label my work here. I'm going to set the y value equal to 0, so -6 times 0 equals 12. That means that term with the 0 just goes to 0, so I get 4x equals 12, and dividing by 4, I get x equals 3. So my x-intercept is the ordered pair 3, 0. For the y-intercept, I'm going to set the x value equal to 0. Just making sure to substitute with parentheses. Now that term with the 0 disappears. I get -6y equals 12. Dividing by -6, I get a -2. And I have the ordered pair 0, -2. So using just these 2 points, it's enough for me to graph the line. So I'm going to go ahead and sketch my xy plane here. Now I could get a third point if I wanted, just to make sure that I didn't make any mistakes, but using the intercepts is quite nice because they are easy to find because you're working with 0, and they are easy to plot because you know it's going to be on each axis. So I'm just getting a rough scale down here, and I'm going to plot each of these points. The x-intercept is at 3, 0, and the y-intercept is at 0, -2, and I could go ahead and just connect them, extending the line and putting arrows on the end. And again, you can get a third point just to check and make sure that it does in fact fall on the same line. Okay, so that concludes part 1 on our linear equations in 2 variables. Stay tuned for part 2 where you'll learn about a third method of graphing.